All right, what's going on? Let's talk about how to find the extrema for a function. So this is a calculus topic, and when we talk about extrema, we're talking about extrema or maxes and mins. So basically, like if you have a function and you have an XY plot and you have some sort of function that looks kind of like this. Obviously, that's a max. This is a min right here. Okay, so those are extrema. All right. So the first thing to note is that the slope of the tangent line at an extrema is 0. Now, what does that mean? Well, for the slope of a tangent, let me say that again. The slope of a tangent line at an extrema is 0, which corresponds to the derivative of a function being 0 at the extrema. Now, what does that mean? So if you look at this little graph that I put up here, what I just said is that the derivative at any of these, like this max or this min, is going to be equal to 0. But why is that? The reason why that is the case is because, so for example, we know that as the original function is going down, that means that the slope, the derivative is going to be negative here. The tangent line that you take is going to be negative, okay? When it's going up, it's going to be positive. So from that standpoint, you can figure between a negative slope and a positive slope, it has to go to 0 at some point. All right. I mean, it has to be 0 in there, in between those two parts of the function. Now, technically, so what you have is, so say for example, I were to just do like a little sample of the tangent line. I mean the derivative of this function here, dy dx. Basically, when it goes from a negative slope to a positive slope, right here at this point, whatever this x point is, you're going to have the derivative crossing from negative to positive. You see? So it's negative. The derivative is negative. It's below 0 until you get to that point where it's at 0, and then it goes positive. That's when the function starts to go up again. So that's basically what's happening. So the first thing that you need to know is, and let me change my color back here. To find extrema, the first thing you need to do is take the first derivative of the function and set it equal to 0. Then solve for x. All right. So you take the first derivative, you set it equal to 0. Because what you're doing is, you know that wherever the first derivative is equal to 0, that is where you have like a max or a min. Okay. So when you take that first derivative and you set it equal to 0, the values of x that you get are going to be extrema. Okay. Now, the next thing I'll say is, and this is not going to be like a number point, I'm just going to put a star here. You can use the second derivative denoted by this kind of stuff to determine if an extreme value, extreme value, is a max or a min. All right. So the way that you determine that is, if the second derivative, and I have notes that you can get from, if you subscribe at mathswaptutoring.com/subscribe, then you can get all of my notes on this. So basically, if the second derivative, so that the second derivative, and you can look at my previous video for how to find the second derivative. Just take the derivative of the first derivative. If the second derivative is positive, that means that the second derivative is greater than 0 at a value of x where there is an extrema, then that means that the first derivative is transitioning from positive to negative, as you see in my little drawing here. And that means that you have a minimum in your original function, okay? So again, let me say that again. So if you take the second derivative of a function and you plug in that value of x where there's an extrema, and it's positive, again, the second derivative is positive at that value of x, then what that means is that means that the second derivative is increasing. And because it's at that extrema, that means it's specifically increasing from from negative to positive. That's what I meant to say. Hopefully I said it the first time. And literally, if it's going from negative to positive, that means you have a negative to positive in your original function, and that is a minimum. So the converse, or the vice versa, is true. So if you take the second derivative at the value of x where there is an extrema and it is negative, if the second derivative is negative, then what that means is that the first derivative, so that would be like, for example, right here. Let me see. And I'm just doing this for the sake of example. We don't really know how the, actually, let me do this because I don't want to be confusing. I'm just going to do a little separate situation here. So here's an original function. And we just graphing a snippet of that. So that's the second, that's the function. When we're going from, so right here, so we know that this right here is the x value where you have an extrema, presumably a maximum, of course. And so you know that the first derivative is going to be kind of like, so it's going to be negative until you get here, and then it's going to go positive. So it's going to be kind of like this. Now, this is not perfect, but I won't get into all those details. But anyhow, that green line is the first derivative. Now, so if you take the second derivative, which is the derivative of the first derivative, and it is negative at that value of x, what that means is, okay, let me make sure I say this right. Actually, I drew that line wrong. I'm sorry about that. I knew that something was a little bit weird. So this actually would end up going in the opposite direction because it's increasing, then it starts to decrease. So if you take the second derivative, which is the derivative of the tangent line here, and it is negative at that value of x, and that means that your first derivative is going from positive to negative, and then therefore that extrema in the original function is a maximum. And so hopefully you can kind of see that. Make sure you kind of go back over this part of the video over and over again until you kind of understand that, and make sure you download my notes. Practice visualization. Let me write that up here. So in calculus, visualization is key. Visualization is key. So you need to really like practice kind of like seeing it in your mind so you can kind of see how all this stuff works. And as you transition between first derivative, second derivative, original function, all that kind of good stuff. All right, now, if you plug the values of x where the extrema were located, so keep in mind, we found where the extrema are located by taking the first derivative and setting it equal to 0. That tells us where the extrema are located, extrema locations. So when you plug those back into the original function, then you end up finding the values of y for the function where you've determined where extrema are, okay? So that's basically the way that works. Now, there's something that I need to note about the difference between, let me scroll in my notes here. So what we've been talking about is relative extrema. So let me see. So if you're trying to find what's called an absolute extrema are basically extrema within a specific range. Basically, the highest and or lowest points. Okay, so basically what you need to do to find the absolute extrema over a range is compare the relative extrema you find the relative extrema by taking the first derivative and setting it equal to 0. And so let me actually amend this here. I should call this relative extrema locations. Be a little bit more accurate here. Relative extrema locations. So compare the relative extrema to f of A and f of B in the range, or I should say over range A, B. Okay. So that way you can make sure that, because it could be that f of A is a extrema, or f of B is an extrema. So you want to make sure those aren't actually higher or lower than the values of the function where you've determined that extrema are by setting the first derivative equal to 0. All right, so what I want to do is, enough of all this talk and everything, let's actually find, let me see. Let's find a, let's do an example. So we're going to find the absolute extrema for the following. So let's do this here. So I'm going to erase a lot of this stuff here because we need to create space. But all you got to do to get these notes is rewind the video. And remember, you can subscribe, mathswaptutoring.com/subscribe to get like my more detailed and beautiful notes, if you will. All right, so we're going to do this using actual math functions and whatnot. Okay, that's good enough. All right, so find the absolute extrema for f of x equals x cubed minus 12x plus 4 over the interval -3, 5. So we're wanting to find the absolute extrema. All right, so this is f of x. So let's find the first derivative. So the first derivative is, that's going to be 3x squared minus 12. Okay. Now we're going to set that equal to 0. So 3x squared minus 12 equals 0. Add 12 to both sides. 3x squared equals 12. Divided by 3. X squared equals 4. And then when you take the square root, x is equal to plus or minus 2. So this is the locations of relative extrema. All right, now what we want to do is, according to what we talked about earlier, we want to take the second derivative and plug in those extrema values to find relative minima and maximum. So we want to see what it says about whether we're dealing with relative minimums or maximums. All right, so f2 of x is going to be equal to, looking at this here, that's going to be 6x, okay? Now, so f of, we'll plug in -2 is going to be 6 times -2, which is -12. So remember, what we said is, if the second derivative is negative, then that means that your if it's negative specifically at that value, that extrema value, then that means that your second derivative is going from positive to negative. So that means you're dealing with a maximum here, a relative maximum. I should say relative max. Okay, so f I should put those dash marks. So f2 of +2 is going to be equal to 6 times 2, which is going to be +12. So remember, if the second derivative is positive, then that means that the first derivative is going from negative to positive. So it's going negative to positive. I mean, I'm thinking about the original, I'm thinking about the function. So it's going from negative to positive, so that means you're dealing with a relative minimum there. Relative min. All right, good. All right, so now what we want to do is we want to, so this is stage 1, this is stage 2. Now in stage 3, we want to plug in the extrema values and the range values, -3 and 5, plug those back into the original function to determine the absolute extrema. What's the absolute max? What is the absolute min? Okay, so let's start with f of -3 is going to be, that's -3 cubed minus 12 times -3 plus 4, which is equal to, that's going to be -27 plus 36 plus 4. So it's going to be 40 minus 27, or 13. Okay, make sure that jives with my notes. Good. All right, so we'll do f of -2 now. So that's going to be -2 cubed minus 12 times -2 plus 4, or that's going to be -8 plus 24 plus 4. So it's going to be 28 minus 8, so that's 20. Okay. All right. So f of +2 is going to be 2 cubed minus 12 times 2 plus 4, going to be equal to 8 minus 24 plus 4. So -24 minus 4, that's -20 plus 8, so that's going to be -12. Okay, and then finally, f of 5, this last value in the range, it's going to be 5 cubed minus 12 times 5 plus 4, which is going to be 125 minus 60 plus 4. All right, so I'm going to do the calculator with that. Being a little lazy here, I admit. Minus 60 plus 4. Okay, and so that is 69. All right, so this is an absolute max. This is an absolute min. And I realize that I may have messed up in my notes, but I can correct that and make sure that's what I upload. But yeah, so there you go. So you found your absolute max and absolute min. First, you took the first derivative, set it equal to 0 to find the locations of the extrema. Next, you took the second derivative and you plugged in those extrema values to determine whether you're dealing with relative maxes or relative mins. Then lastly, you plug every value in to the original function to determine the y values where those extrema are located, to see what your absolute max and absolute min are. Hopefully this is helpful. Make sure you watch as much as you need to. Share if it's been helpful. Make sure you subscribe, like this video as well. Thank you guys, and I hope to help you in the future.